Hi, I'm James Donald. I'll be giving a retrospective on the paper, Techniques for Multi-Core Thermal Management, Classification and New Exploration from ISCA 2006. I'd like to start by thanking my co-author and thesis advisor, Margaret Marnozzi, in addition to ACM, IEEE, and the ISCA Program Committee for awarding us the 2021 ISCA Influential Paper Award. This work was done while I was a graduate student in the Department of Electrical Engineering at Princeton University. As of today, Margaret is the Hugh Trumbull Adams Professor of Computer Science at Princeton, and I'm currently at Facebook under Facebook Reality Labs. I should state here that the views presented do not represent those of my employer, nor can they be taken as any indication of current or future Facebook products. So let's start by going back to 2006. Power and thermal modeling tools were maturing. We built upon frameworks including Watch and Hotspot, papers which incidentally won this ISCA Test of Time Award in 2015 and 2018, respectively. As for where we were on multi-core chips, remember this is before even the release of Intel's Core 2 Duo family. Mid-2006 was only shortly after the introduction of its predecessor, Core Duo, and comparable offerings in AMD's Athlon and Opteron lines. In the mobile space, the iPhone and Android operating system had yet to be announced, and when these did arrive later, they would remain single-core for many years to come. At the same time, the research side of multi-core work was rapidly advancing in academia and industry. Many ISCA 2006 papers were about different aspects of multi-core design, shared cache hierarchies, networks on a chip or NOCs, and more. This paper was among those, particularly on multi-core thermal management. Although our study focused on homogeneous cores, at this time we were seeing heterogeneous designs under serious consideration throughout the industry. There had also been many papers on formal control, such as PI or PID, proportional integral derivative controllers. Our paper built upon this with a multi-loop formal approach. We can divide this paper into two main contributions. The first is that of demonstrating distinct application thermal behaviors with real-world measurements. And we were able to do this by taking advantage of how vendors had begun to open up APIs to query sensor data more easily. The second is our exploration and taxonomy of multi-core thermal management approaches. We modeled these under three axes. The first is distinguishing stop-and-go or halting sleep policies versus those of dynamic voltage and frequency scaling, or DVFS. The second axis decides whether this is applied on a per-core basis versus globally. The third is that of our migration policies, when an application can be preempted and swapped out to run on a different core. And here we consider whether that migration decision algorithm primarily uses conventional performance counters versus our proposed incorporation of thermal sensor readings. So let's fast forward 15 years to where we are today. Microprocessor dynamic power and thermal management is universal. For example, in modern desktop CPUs, we have P states, which embody DVFS, as well as C states for different degrees of pausing or sleep, and comparable functionality in smartphone chips. On-chip parallelism is also universal. Earlier I mentioned that in 2006, we were barely into the introduction of dual-core PC CPUs. However, today, you'd be hard-pressed to find a desktop, notebook, or smartphone with a single-core design. In addition to the increasing number of cores, we've seen a marked increase in heterogeneity. I not only refer to CPU designs of big and little cores, but also trends of increased general-purpose computation on the GPU, programmable DSPs, and the advent of dedicated neural network engines, or AI accelerators. Obviously, our paper did not cause those trends, but it did lay some of the groundwork for analyzing thermal management issues in the face of them. In closing, again, we are thrilled and grateful to receive this year's ISCA Test of Time Award, and hope you enjoy the rest of the program.